Hello, everyone. Thanks for coming here to listen to us talk at the end of a long day. So we're going to be giving a talk about using game technology in progressive web apps with BabylonJS. I'm Zach, this is Numa, and we're the co-founders of Jig Space. So we're going to take you through a bit about what Jig Space is. We're going to tell you about our technical journey from using Unity to WebGL, particularly with Babylon, and how we apply principles of game development to non-gaming applications to make them kind of a more enjoyable and delightful experience for users. And we'll give you a demo of what that all means. So what is Jig Space? Jig Space is a platform for creating and sharing interactive 3D instructions for anything. We have a vision for the world where you can look at anything and you can say, how does that work? And that information is available to you immediately in 3 dimensions on whatever device you have with you. So today, that device is a phone. Tomorrow, it'll be AR and VR. I'm going to give you a little example now, just quickly show you what a jig is. So this is our website, jig.space, and here you can see all these jigs. Each of these is a jig that is being created by users using our jig workshop. So if I have a look at this, it's one of my favorite jigs. This is how a lock works. So with a jig, you can interact with it, you can rotate around, you can zoom in, you can double click on things and see what they are. You can interact with this, but you can also step through each stage of this jig and it'll show you how the thing works. So here in this case, it shows you that there's the shear line there and the key opens and allows you to get in. So that's a very simple jig, but it shows very clearly what we're trying to do. So you can imagine that this can be applied to so many different things, and it's all created and deployed here on the web. So how do we get there? Like if we have this vision for a world where you've got this access to this information immediately, there are 3 things that we need to build for this to be a reality. Firstly, it needs to be easy to create. You need a tool that lets you create these interactive instructions easily. It also needs to be easy to transport. So these files have to be small and they have to be easy to throw around the web as quickly as you can. And it needs to be easy to view, which means viewers have to be ubiquitous. Whatever device you have is where you need that information, and we need to be there. That is what we need to build our vision for Jig Space. So Numa is going to take you through a bit of the technical journey that we've gone through to get here.
Thanks, Zach. So Zach and I are from a games development background. So we've been making games and working with 3D technology for years. So when we started working on Jig Space, we decided to build it using Unity. So Unity was great because it let us quickly prototype and build different viewers. It lets us deploy to multiple platforms at once. So that checked most of our boxes. But there was one thing that Unity didn't do very well, and that was exporting for the web. So the WebGL builds that we were getting out of Unity ended up being 50, 60 meg JavaScript files that people had to download and then parse before they were even able to start viewing our content. So that was way too long, 50 seconds. Anything pretty much today that's more than 5 seconds, and people are just going to leave. So that didn't pass our second requirement, which was that jigs have to be easy to transport. They have to be available immediately when you need them. So yeah, that's when we realized we were going to have to rewrite the entire thing for the web using JavaScript and WebGL, which was pretty terrifying at the time because I had never seen a line of JavaScript in my life. So we started having a look at different graphics library, and so we had a look at 3JS, which is really powerful, and there's lots of people doing great things with it. We also found BabylonJS, and Babylon turned out to be perfect for us because it's more of a game framework than just a graphics library. So it had all the things that we normally use in game engines already built in. So Babylon has classes to handle controllers and different types of cameras and loading assets, textures, sound, 3D models. It's got animation. It's got web VR. Enabling VR in a BabylonJS app is only one line of code. It's just a matter of declaring your camera as a VR camera instead of a normal camera, and that's it. There's nothing else you have to do. So that was great. So pretty much BabylonJS can do anything other game engines do, but it's got one major advantage. It's that it's got a tiny, tiny footprint. The entire Babylon library is only slightly over a meg. So it loads and it runs really fast, even on phones. So that was perfect for us. And they've also got a really active community. So there's always a lot of people adding new features, fixing bugs, and helping you out on the forums. So that's great. And it made the transition from Unity to BabylonJS very easy for us. So in a couple of weeks, we were able to pick it up and rebuild the app, and we had the Jig Space viewer running on the web again. And yeah, it changed everything for us. The load times went down from around 50 seconds down to 3 to 5 seconds. So yeah, that was incredible. The file size went down from 30, 40 megs down to a meg and a half. So immediately it was a completely different realm for us. So from having all this content that was inaccessible, we ended up having our entire library available at any time. But there's more. Once we had a solid and fast web viewer, we were able to take advantage of Microsoft's hosted web apps. So a hosted web app allows you to turn your website into a desktop application without having to write a single line of code. So you build this app in Visual Studio, and you just point it at your website, and you end up with a desktop application that people can download, can install it, have a shortcut on this desktop, they can pin it to their taskbar, and it's always in sync and always up to date with your website without you having to do anything. And you can also take advantage of the desktop environment, so you can use new peripherals like the dial, for instance. So that's really good. And what I like about it is that it gives you a new approach, which is a web-first approach. So rather than building a heavy desktop app and trying to constrain it into a web context, you start by building something that's light and fast, and then you deploy it to other platforms. And that's really important if you want to build great applications that your users are going to love. But the speed isn't the only thing that you need to worry about to build great experiences, and Zach is going to tell you a little bit more about that.
So we wanted to not only use our experience with technology, with game technology, with Jig Space, we wanted to also use our experience with design. So the bottom line for us is that 3D is difficult, and our tool is supposed to be for everyone. They should be able to share their knowledge in a simple way in 3 dimensions. Typical 3D software is hard to use. It's high-end software, lots of menu. You're usually doing work in it. So we needed to create something that was delightful for users, and we applied a lot of the principles that we understood from game development to that. So the first one we used was this concept of light versus heavy. So there's not endless menus to dig through. The information that you need when you need it is available when you need it. So you click on something and it brings up a menu for you, and it doesn't clutter you with a lot of options. It's just the things you need. We also made it juicy, so all the interactions, when you click on something, menus pop out, the movement is nice and enjoyable, so at no stage do you feel like you're doing work, you feel like you're using an app that responds to you. And the other one is short feedback loops. So in typical applications, it's a long time between having the concept, what you have to execute, and actually seeing the result. We wanted to shorten that loop as much as possible, even within the interactions themselves. So when you click on something, you get a response. But also the entire meta loop of creating a jig should be as short as possible from concept through to deploying it on the web. With that, we're able to create a tool that is simple, useful, and fun by applying all that. And using Babylon actually helped in the pursuit of that, because it is a game engine. It already has all of that language built into the engine itself. So now I'm going to give you a demo and take you through the process of creating a jig and viewing it on the web. So let's see how this goes live. Okay. So this is the jig workshop. I'm going to make a very simple jig about how to plug in a USB. It's going to be the definitive guide. So this is the jig workshop. Very, very simple. You can move around, manipulate in 3D space, and like we said, it's light. There's not a heap of menus here. There's not a lot of options. So I'm going to bring in a 3D model. And I have this model of a USB that's on our model store. So here you see it brought in, and I'm going to go through and set up the scene. So there's a few things you want to do. It's coming with no colors, so I'm going to go through and just give it a bunch of colors. So here we've got the menu for each element. As you can see, it kind of moves around and responds with what you're doing. And there are 5 main tools here that you can use. You can position things, you can rotate, you can scale, you can give them labels. So this is the plug. You can switch that on and it'll stay with it. And you can also set the color. So let's make this let's make it a gray. And here, now this is a metal part of the plug, so I'm going to apply a material to it that makes it look like metal. That looks good. And what kind of USB is it? Let's make it USB 3.1. It'll be faster. And this is a Microsoft conference, so this can be beige. Oh, it's a dig, sorry. I'll make that metal too. Okay, so here we've set it up, like really simply now. We've got basically how we want it to look. But when I move this, I want everything to move with this whole piece. So I'm just going to attach these pieces together. And there you can see the response that you get immediately from attaching something. It pops to show that, yes, these things are now connected. So now when I move the plug, you can see it all moves as a single assembly. So let's go through and start creating it. So I'm going to add a step. And on this step, I'm just going to slide it in. Now, this is a definitive guide on how to insert a USB. So I'm going to go through all the steps. The first one is realizing that you've got it the wrong way around and flipping it over. Okay, there. So I've flipped it over. And now I proceed to the next step, which is to realize it's actually wrong. And I'll go back to the original configuration and move it back in. Easy. Perfect. So now I'm just going to put in a comment up here. Easy. What? If I can get this right. It's a typo. Okay, so now we've finished our jig. We can step through and see what happens. So we go in here first, go to the next step, move in, and there we've finally inserted the USB correctly. That's how simple it is to create a jig. Now, all the jigs on the library were created using this tool, and that's it. Like with these simple tools, you can create pretty much any step-by-step instructional content you need. Now, if we want to publish it, I can just set it to public. It'll tell me that I need to take a thumbnail for it. So let's go to the first stage. Just position it where I want. Take a snapshot. And now all I need to do is click view. And that's live on the web right now. You can look at this right now live on the web. Immediately it's available in Babylon. And we can step through those instructions. That's how simple it is. And we wouldn't have been able to do that if we'd just been using Unity, because it's too slow. There's no way for us to load it and get that immediate feedback. So I've created a thing and now I've gone through the entire process and I can see it. Babylon and game technologies enable us to be able to do that. And these can deploy to VR and AR and everywhere. If you have this link, you can copy it and give it to someone and they immediately have access to it. So this information is now available everywhere, which is what we're trying to do with Jig Space. The other great thing is that it is also in the progressive web app. So this is, again, immediately available. We can go here, we can see it in the library, and we can just go in and look at it again. This is how Jig needs to be. For us to achieve our vision, we needed this technology. And it's been fantastic for us. So I'll just jump back in here. In conclusion, game technology is solving a lot of problems right now because 3D is... We're about to see a paradigm shift towards 3D technology. We're going to see all these interfaces that are 3D. Game technology is going to play a big part there because we've been rendering 3D graphics for a long time now, very fast, and we're going to need to do that. And Babylon brought the speed we needed to realize our vision. And also, progressive web apps represent a completely new paradigm for developing because you start with something light and you can deploy on a desktop with a light application. And again, Babylon was really helpful with that. So for us, we applied the principles of game development and technology to non-gaming applications to create delightful applications. And I'd encourage you to look through that kind of technology and see for yourself how you can use it, not just the tech, but also those principles to create things that people really enjoy using. Because I think that'll be really important going forward, as 3D is something that everyone will be interacting with. So yeah, you can go and check out our website, jig.space. You can also, please go have a look at Babylon. It's a fantastic library. And follow us on Twitter. Thank you.
Thank you.